Now here the question is, let an be a sequence of real numbers, then this limit n tends to infinite an, it exists if and only if which of the following option is correct. Now suppose we assume that the sequence an, it is a converging sequence and it converges to this limit L. Now we consider these three limits, say limit n tends to infinite a2n. Suppose this value is L1, limit n tends to infinite a2n plus 1, this is L2, and limit n tends to infinite a3n, and this is suppose L3. Now we know that if the sequence an, it is a converging sequence and it converges to this limit L, then any subsequence will also converge to the same limit L. So this a2n, a3n plus 1 and a3n, they are all subsequences of this sequence an. From here we can say L1 must be equal to L2 and it must be equal to L3. So if the sequence is convergent, then all the subsequences, they'll converge to the same limit L. Now we'll discuss the case when B implies A. That is, all these three limits, they exist. Now suppose limit n tends to infinite a to n, it converges to L1, and this limit an plus 2, it converges to L2, and suppose L1, it is not equal to L2. Now if we consider the sequence a6n, then a6n, it is a subsequence of a3n, that means it should converge to L3, and a6n, it is also a subsequence of a2n, that means it should converge to L1. So from here we'll get this condition that L1, it must be equal to L3. Now we consider this a 6n plus 3, then a 6n plus 3 is 3 into 2n plus 1, and we can also write this as a 2 into 3n plus 1 plus 1. Now this is subsequence of 3n, so it will converge to L3, and this a 2 into 3n plus 1, it is a subsequence of a2n plus 1, it will converge to L2. So this limit n tends to infinite a3n, it will exist if and only if L1 is equal to L2 and it is equal to L3. And when all the three limits, they are equal, then this limit n tends to infinite an, it will exist. So answer to this question is option C.